Today, ladies and gentlemen, I want to go through a couple examples that you can use for review. We'll be talking about how to complete the ions and isotope table that was assigned in class using a few rows as an example. First, we want to make sure that we know how to do each column. Protons are always equal to the atomic number. Neutrons are mass minus protons. The electrons are where it gets a little tricky, but everything goes back to the charge. So the charge of that particular atom will equal the protons minus the electrons. If those two things are equal, the charge will be 0. If I have more protons, I'll get a positive charge. If I have more electrons, I'll get a negative charge. Our mass is our protons plus our neutrons. Notice I'm using my symbols there to save a little space. Atomic number equals the protons. And then atom or ion is simply deciding, is there a charge or is there no charge? So it is an ion when it has a charge. So let's take a look at the one that is directly above the U example. So there's a row that starts with U. We're going to look at the first example above it. We are told that it has 20 electrons. We are told that it has an atomic number of 17, and that's all we're told. So the first thing we can do is we know that our atomic number is equal to the proton, so I'm going to place that as a 17 over here. Also, we know that because the atomic number tells us the element, when we look at the periodic table, we know that it is the element of chlorine. Okay. When we take a look, there's no information to suggest what the mass is, so we look at our periodic table and round to our nearest mass. Our chlorine mass then would be a 35. Knowing that the mass is the protons and the neutrons, if I subtract the protons from the mass, I will have the neutrons. So 35 minus 17 will give me a number of neutrons of 18. Now when we complete our symbolic notation, first we put our mass in the top left, so we had 35 for this one. For atomic number, that's our protons right below. And here when we take a look, it says that it has 20 electrons and 17 protons. That means I have 3 more negative charges than positive charges, giving it a charge of -3. We would call that an anion. That's our name for a negatively charged ion. All right. Next example I would like to do. We'll take a look at the one that says Mn plus 7. So that is one of our given pieces of data. And we are also told it has 28 neutrons. And that is all we are given. Since it's manganese, we can look up on the periodic table that it has an atomic number of 25, which tells us its protons are 25. Once I know one, I automatically know the other. We know it is a plus 7 charge, which means it has to have 7 more protons and electrons. Since I can't change the protons or I change the element, I'm going to subtract 7 to get my electrons. So 25 minus 7 is 18. The mass, since we were told it has 28 neutrons, I have to use that number and add that to the protons. 25 plus 28 gives me a mass of 53. The charge here makes it a cation. Positive, remember the positive sign is in the name. And I'm going to place my mass over my atomic number to complete the symbolic notation. The last thing that I'm going to point out is that if you compare this to the periodic table lists the mass of manganese as rounding to 55. 55 is not equal to 53. So we would call this an uncommon isotope because it is not equal to the mass from the periodic table. These two examples give you some different anions and cations, pointing out how we use the given data to be able to calculate the unknowns.